I'm not quite in the middle of nowhere, but I am a little lost. And instead of using the sun's position to reorientate myself or just blindly run in any direction, I'd better check with the satellite. And this verdict is clear. The street is that way. But how does such a sat-nav even work, Mr. Science?
It looks like Mr. Science is playing hide-and-seek today with his sat-nav, and his sat-nav seems to always know where he is, no matter if he's hiding behind, in front, or even on top of the tree.
Okay, so here underneath, they are surely not gonna find me.
And yet we did, Mr. Science. The only option for you is to hide inside a house.
Yes, I know. I just wanted to make sure. This sat-nav receives waves from the satellites in space, and those waves are only stopped by thick walls.
Does this mean that as long as you're outside, the satellite knows exactly where you are?
No, not exactly. The satellite only knows its own position and sends this information at speed of light to Earth, and my sat-nav receives that. And how the satellite managed to pinpoint me exactly on my sat-nav map, that I'd like to show you in an experiment.
And because Mr. Science can't just fly to the satellites in outer space, he will simply do his experiment in the town park.
I'm now standing somewhere in the park. I have my map as well as my sat-nav, and I don't have a clue where I'm at. Around me there are a few satellites sending me messages.
Right, satellite number 1 is placed at the fountain in the park and is permanently sending messages with its exact position and time of day in all directions. Joseph's sat-nav is now receiving these messages. In our case here, the mailman will deliver the data.
This message tells me exactly where the satellite is and when the message was sent. I kept track of the time I received it, and with that I can precisely determine how long the message took to get here and how far away the satellite is.
Wie lang de message gebraucht wird, und wie weit der Satellit fort ist.
To be able to determine this, Mr. Science has to do some calculations first, and if his formula is correct, the result should be 150 meters.
That's right. On my map, this distance is exactly 150 meters. The satellite is located here at the fountain, so I must be standing somewhere on this circle.
As you can see, one satellite isn't enough to determine Joseph's exact location. He has to wait for another message from another satellite located at a different position in the park. In other words, we can find him here at one of the 2 points at which the circles intersect. Here on this map, on these 2 points. Only with a third satellite will it be possible to find his correct position, and if Mr. Science solved all his calculations correctly, he can only be at this exact spot.
That's right. A real satellite system works similarly, only that with GPS, messages travel a whole lot faster than this and come from far, far away in outer space. What's important here is the clock time, because it allows us to precisely calculate the distance between sender and receiver. The more precise the clock is, the more precise the distance.
In every satellite there is a highly precise atomic clock which sends its time with an error in measurement of only a millionth of a second at speed of light, that's 300,000 kilometers per second, onto Earth to the sat-nav. The sat-nav then compares that time with its own. Using the difference in time, the distance can then be calculated. So that this can work, both clocks have to be synchronized. With Mr. Science's watch, you could just about tell if he's walking on Earth or on the moon.
Right, and it's really not that easy to get 2 clocks to move exactly in unison. A difference of only a thousandth of a second already causes an error on our globe of 300 kilometers. And then we don't know whether we're in Luxembourg or in Paris. Here we've got another problem, however, and that's where Einstein comes in. Remember him?
Und du könnt den Einstein ans Spiel. Kann der jo.
Einstein's relativity theory says that when you travel quickly through space, then time goes by more slowly, and a satellite travels really fast through outer space.
It may be difficult to understand why time in a satellite goes by more slowly, but Mr. Science, we'll just believe you this time.
Yes, so time in a satellite passes slightly more slowly than here on Earth, and we have to take that into account. It may only be an error of a billionth of a second, but without Einstein's relativity theory, it would never have been possible for a sat-nav to determine our coordinates to up to 1 meter exactly.
So next time you use a satellite, remember, it was our good old Albert who made this technology possible today.